So studies show that lighting and HVAC consume 70% of a building's energy use, but typically we take these systems and we control them separately in these silos. And very rarely do we actually go across and truly do a real integration where we're sharing information back and forth in a platform where we have two-way communication between the systems. But your energy meter is on the building. Your meter is not on your HVAC system. Your meter is not on your lighting system. It's on the building itself. And so, if you think about intelligent buildings and smart buildings, these things that we think about for the future, that technology exists today. It's readily available. Such tremendous advancements have been made in the technology that you can very simply pursue integrating those systems as you're looking at your HVAC system and your building management system, as you're looking at your lighting system. That's such an easy consideration to start thinking about and pursuing. And so there's so many benefits to going down that path. One is simply just increased functionality and smoother ease of operation. So I want to make a point about the fact that not all humans need the same amount of light, period. And then also we need different amounts of light for different tasks. So if I'm sitting and I'm on my computer, I need a different amount of light than if I'm sitting and writing something or taking notes. And so being able to give people that flexibility is a tremendous asset to making them feel more comfortable within that space. But there's also another aspect of this, which is data related. Having the information about how a system is running, information is power. So understanding that we have a particular area that's using more energy, why? Should it be using more energy? With this information, we can dig down. If you just have a standalone occupancy sensor, you don't have that data. But when you have a system like this and you're integrating these systems, not only do you have the data so you can fine tune the operations of your space very easily through one platform, you're going to get deeper energy savings by having that information, but all that information is easily accessible to you through a single platform. So you don't have to go make changes to the lighting system, make changes to the HVAC system. You can do it in one central location. And by integrating those systems, you really do bring the most value to the space. You make it more flexible and more comfortable for the users, and you can get the deepest energy savings by optimizing the use of those systems. And so this is something that we at Trane are actively focusing on, is working with lighting manufacturers to make sure that this technology is accessible to customers, so that if they have a particular lighting control system that they want, we can make sure that we give them all the functionality that they need, because really what's important is that they have a seamless experience and they meet the needs that they have. So if you have questions, this is something that there are a lot of subject matter experts out there on. We're really focused on this, and we definitely want to help you make your space more increase the ease of operations. Oh, sorry, next slide. I forgot that I don't have control of the slides. Okay, so let's dig into some of the benefits. So we've talked about comfort, flexibility, and energy savings. So if you do have that sensor and that individual control of each fixture within each space, really being able to fine tune the use of the system to meet each occupant's needs in their offices, not just the president, but anyone in any office. Even people within cubicles may have the flexibility to select their own lighting based on the task that they're performing, or based on a light level that works for them across all tasks. A really simple thing to do with integration is to share schedules between the systems. So you have one place where that schedule resides, and when that building is no longer occupied at the end of the day and no one's in the space, not only shutting off all of the lights or changing the temperature set point, but being able to do it all in one place. Probably one of my favorite use cases is using the occupancy sensor data to help extend those energy savings further. So someone walks out of the space, 10 minutes passes, no one else has come in, the lights shut off, but also being able to close that VAV damper so that we're not conditioning a space that's unoccupied. And there's tremendous savings, as you can see, from utilizing that, and it's very simple to do through integration. Another really great use case was being able to aggregate the HVAC and lighting energy reporting on one dashboard. So, if that consumes 70% of your building energy use, being able to have one place where you can go and where you can see that. And a lot of companies really care about their energy use and really care about saving energy. And so being able to promote that and let employees know and customers know, hey, this is what we're doing to help our environment, and having one dashboard that you can go to for that. I talked about the fact that 70% of building energy consumption is lighting and HVAC, but another really nice feature about these systems is that you can also control plug load with them. So you could say a bank of printers or a bank of coffee makers, we want you to be controlled by the schedule, or in office space, if the space is unoccupied, you can turn off the monitor of a computer or things like that. So you can do multiple different things. I actually deployed that in a building in Texas years ago, and we controlled all the coffee makers within a space, and we saved $16,000 a year in energy just by essentially reducing the plug load of those coffee makers with a few $100s worth of additional material, because all we had to do was tie those coffee makers to the system. And then once they were tied to the system, they were tied to the schedule, we could tie them to the occupancy status of that zone. Another really exciting use case that gets used less frequently, but I foresee this becoming a bigger use case in the future, is deploying demand response signals to both the HVAC and lighting control systems. So if you think about your energy bill and you think about the supply and demand of energy use on our grid, as demand starts to reach that peak of where supply is, having a demand response program where people can reduce their energy use on demand helps us prevent brownouts and blackouts. Additionally, if you look at your energy bill and you really dissect it, you realize that whenever you have a peak on your energy bill, that peak impacts your energy bill throughout the entire year. So you can do something called peak shaving. Now, generally what people do when either peak shaving or load shedding is another term that's typical when you're reducing your building energy use on demand for a demand response event, is they increase their temperature set point. Well, one thing that we can do that's really slick with integration is we can, over the course of 2.5 minutes, dim lights 50% without the human eye detecting a difference because of the way our pupil responds to light. And so for a short period of time, a few hours, we can reduce the light levels in that space without it having a negative impact on anybody in the space. You can, your company can get revenue from participating in the demand response event. It can have an annual impact on your energy bill because you've reduced the peak on your peak days. And then in addition to that, because we're reducing those light levels, we're also reducing the heat generated by that light. And so as we're raising the temperature set points, we're making it more comfortable for the people in that space during those events. Next slide, please. Thank you. So I want to talk to you all about a customer that I refer to as the Baker's Dozen. And the reason I refer to them as the Baker's Dozen is because they are a commercial kitchen that's available for lease for tenants. And those tenants are using this space to bake products, and they happen to have 13 rooms accessible for lease to package those products. And so anyone who's ever gone and gotten a Baker's Dozen of bagels knows that you get 13 bagels instead of 12. And so there are 13 rooms in this space. And so when we started talking to them, the building owner manages the energy bills, so they're responsible for that. And they also want to understand how their space is being used. They have tenants in the space 24/7, and they're experimenting in this, and they're figuring out their business model. And so that they wanted to have access to how is the space being used, how much energy is being used, but they also, as all customers are cognizant of what they're spending for a system like that. So they were looking for a cost-effective way of getting this information and being able to control their space and really optimize it. Next slide, please. Thank you. And so when we spoke to them about what a connected lighting system could do with integration to their building automation system, they had one platform by which they could control both systems. So only one platform that they had to get into to do any monitoring, any reprogramming, any information that they wanted. And that one platform would pull in all of the lighting as well as all of the HVAC data. It would give them an energy dashboard similar to what you saw Kenny show, so that they could see both systems on one graph and understand how their building energy was being used as tenants were occupying the space, as well as when tenants were not in the space. It gave them occupancy reporting. That's something that we haven't really talked much about, but having visibility to when your space is being used and really understanding how that space is being used by those tenants and being able to track that with energy use. How is energy being used when people are in the space? How is energy being used when people are out of the space? And using that information to make smart decisions about how to optimize that building. And the greatest thing about this was there was a sensor on every fixture. That sensor has occupancy control. That sensor has a photo cell built in. It has an energy meter that's pulling that data. It has its individual address. And the payback on this project was under 5 years. And so a lot of people think that this technology is not accessible because of cost, and that's absolutely not true. If you really understand what you're looking for, and you can turn to experts who can help you select the right system for you, you can do all of this truly very cost effectively.